Assalamualaikum to my panel, Encik Faiz and Encik Amir. My name is Muhamad Izman bin Jamaluddin. I'm from for BMMH. So my supervisor is TS Azwan bin Aziz. So today I want to present my bachelor degree project, which is the title, the efficiency of the local exhaust ventilation LV ducting system through the assessment of the duct pressure at Innovation Laboratory UTEM. Okay, for this chapter, which is the introduction. So local exhaust ventilation is the engineering system frequently used in workplace to protect student, employee, staff from the hazardous substance, which is the LV have the hood, can capture the dust, mist of chemical in their workplace, and then LV has the effective system, is important, is well designed and installed, used correctly and properly maintained. Which is LV must be correctly proper designed to better performance. Okay, for problem statement. Okay, equipment that capture and filter harmful emission is often necessary in order to maintain a safe work environment. Okay, statement 1 is the problem include the exposure to compound risky substance contaminant, and then the second one is state of the lung is identified with exposure is no small grouping of airborne contaminant for critical number. And the last one is so by collecting the latest data and information about the airflow and pressure should be recorded and documented to provide an effective system. Okay, for objective, first to determine the efficiency of operation condition through the duct pressure in a level ducting system. This is the main objective, and then these research have two specific objective. First, to measure the static pressure, velocity pressure, total pressure and velocity flow for the LV system. And then the last one to test the effectiveness to ensure operate in good condition and according with the standard. And then we have the two scope, which is one is this research collecting data related to assessment of the efficiency of LV system, and then this research will use equipment, a velocycle multi-function ventilation meter, and pitot tube, and also tachometer for checking RPM. Okay, for the literature review, I have put 3 for my research for this slide. And first one is about the mechanical ventilation. We all know LV system is one of the mechanical ventilation because we have a fan extract the contaminant out from the workplace. And then the second one is LV take out of the fog, gas, fume and vapor have a chemical out from the workplace. So the LV system have the 5 main component, which is one is hood, second one is duct, third is air cleaner, and then fan, the last one is stack. Okay, and then for the last one is local ventilation, exhaust ventilation system and fundamental, which is to test the performance of the LV system. We have to collect the data, which is the total pressure, static pressure, and the velocity pressure. Okay, for the methodology, in this research, environmental assessment of the local exhaust ventilation LV system will be done on the selected LV system at Innovation Laboratory (FFTK). So in that lab, I have collect the static pressure, velocity pressure, total pressure and velocity of the flow of the system. And then the method I use is velocycle multifunction ventilation meter, pitot tube and tachometer. So the next slide is for a chat project. Okay, for this slide, the advancement of general methodology. First one is start, and then planning of the study, literature review, research methodology, preliminary data gathering result, And then construct the study, compare the data, collection, conclusion and recommendation, report writing and end. So this is the PSM2. So we focus to the conclusion, discussion and result. Next sheet. Okay, for the flowchart is first one is start, and then we go the walk through inspection, collect the data, fill in measurement. So which is they have the static pressure, velocity pressure, velocity for the system, and then we compare with the standard. If the data is acceptable with standard, we proceed to the result and discussion and analysis, and then conclusion and recommendation and end. If the data is not required, is not suitable for the system, we use the method to overcome to collect the data again. Okay, for the equipment that I use for this research, first one is pitot tube. For the pitot tube, I use for static pressure and the total pressure. And then second one is Volatile multifunction ventilation meter 9565. So this one is I use for detect velocity, airflow, temperature, humidity. So this have the multifunction. And then last one, I want to check the RPM of the fan, motor fan. I use the tachometer, which is the check the speed estimation mechanical turning apparatus. Okay, this one is one of the LV system that I choose for my research. So this system has been selected by me to conduct the study on the effectiveness of system operation. The system have the 19 points and have the four different hood, which is hood, downdraft hood, capture hood, boot hood, floor hood and canopy hood. So this picture show you the area I take data and sampling point. Okay, for this slide is most important, which is the result and discussion. For the result of the efficiency was widely recognized. I use the SI track proof software, which I conclude the data. Okay, so the data I take is static pressure, total pressure, velocity pressure, flow rate, velocity and brake horsepower. Okay, and then expected result for efficiency of LV system. Okay, the first one is static pressure, velocity pressure, total pressure and velocity of the flow of the system can be determined. And then you set data and information static pressure, velocity pressure, total pressure, system recorded and documented and can compare with the latest one. And then the performance of the LV system of the innovation laboratory can be assumed. For the first calculation is data collection of air flow rate. So I have used the formula area by r squared, and then transport velocity Vp, so 4005 square root by V4, and then flow rate QVA. So this table they show the first point until the 19 point. Okay, for this slide, for the calculation for the pressure, so the total pressure, they will use the formula SP plus the VP. So SP and TP must be negative value, so VP must be positive. So this is the calculation. So the table show the first point until the 90 point, show the velocity pressure, tensile pressure and total pressure. Okay, for this slide, calculation for fan static pressure, fan total pressure and brake horsepower. So we can see the calculation FSP and FTP. And then for the brake horsepower, so we can see the total horsepower and comparison with the experiment and theoretical. So the observation, the condition was grounding, the median variation motor condition was 140 degree. As a result, table show comparison test value to design the motor speed when static pressure and flow rate a little difference, while the value of brake horsepower reduced almost half compared design for fan test. For the graph, we can see the 19 points have the different duct size, which is 8 inch, 10 inch, and 7 inch. So based on the figure, the ducting needs to be sized correctly. To carry flow, they should be oriented to such a way as to prevent turbulence and must be of sound with a solid construction. Okay, for the data analysis velocity, so as you can see the different flow, we can see at the chart. So the first point until the 9th point, we have the different data. So mostly they for the point 4, 5, 6, 8, 9, 10 and 11 and 12 need to rechecking or needs to be well maintained for better operating flow system as to be able to be carried out the contaminated air out from the lab. So the line of the green is the standard. I refer to the SCGIH 2008. For the next slide is about the flow rate. So we can see the chart, and then the different value which first until 19. So based on the result, most value of flow rate for various point is satisfactory condition and specified to achieve the initial capture contaminant to carry out the contaminant to filtering system compared to the 0.6 and 8. So it's a little bit unsatisfied lah for the system. Okay, for the velocity pressure, we can see 0.6 and 8 is mostly is bad situation lah. So the figure show the value velocity for each point proper flow compared to 0.6 and 8, and the importance of velocity pressure to improve the system performance or maintain proper flow rate to ensure equipment comfort during their lab session. Okay, this slide is most important because it is a static pressure. This static pressure must be negative value. So we can see almost the data, the 19 point is very good conditions. So as a fan increase the pressure inside the duct or the exhaust side, and air move from the high to low pressure is expelled from the duct. So the result in the reduction pressure in the duct on the other side of the fan, so that is lower than atmospheric pressure, causing airflow into the system and providing the hood and the system well designed. For the last one for the result discussion is about the total pressure. So the total pressure is almost you have the 19 point is the good and must be negative value. So the total pressure, the sum of the static pressure and velocity pressure is measured into the flow at every point where all the value is negative sign. So the 0.9, 17, 18 and 19 is the highest value, is the compared to the value is other value, and the value for the each point has shown the system is still good condition where rarely used during condition movement control order. So the system is rarely used because during the MCO. Okay, therefore the conclusion, the objective of the research has been achieved with the all new data were recorded, and then all about efficiency on local reservoir ventilation system, the static pressure, total pressure, velocity pressure, flow rate, velocity and brake horsepower were compared to the American Conference of the Government Industrial Hygiene, SCGIH, and Department of Occupational Safety and Health, Malaysia, DOSH. And then the last one, my recommendation, the maintenance of the elevator system must be maintained every 3 or 6 months. They will help to extend the performance of the system and engineering control equipment. Thank you.